right, we're now into the proof section of Unit 4, your favorite part. Okay. It's going to be a little rough from here on, but we still are going to use the same tools that we used in the proofs before. You can do this. I will explain how. You got it. Okay. So we just talked about how all of these congruent parts of the triangle in lesson 4.4, they impact each other and they match. Okay. Well, we also talked in the lesson before that, 4.3, how about the sides and the angles match? Okay, there's a relationship between those sides and those angles. So if we have enough pieces of information to say that maybe two sides match and an angle match, we can use that to determine, well, two sides in an angle, well, that angle is going to match with the third side, so we can figure out that, hey, yeah, triangle A is the same as triangle B. It's the same kind of logic, it's just exploded up and we're making like conjectures about it. So we have different ways that we can prove triangles are congruent, and the most easiest, the most basic, we're starting out with side, side, side. If you have two triangles where all the sides match, just like this, then the triangles are congruent to each other. Three matching sides makes two matching triangles. So here in this proof, we've been given a lot of things. And that's fantastic, because I love when they give me a bunch of givens. This is the first thing they gave me. This is the second. And it tells me about the midpoint. Okay. So I have three pieces of given. I only have two more to go. In proofs like these, in these triangle proofs where we are trying to prove two triangles are congruent to each other, please label your pictures. It makes everything easier. Right here it said PQ is congruent to ST. So over here, PQ is this one. One tick mark, ST, one tick mark. Please do that. Match them up. QR is this side here. QR, two tick mark. TR, two tick mark. Match that up. And then it tells me R is the midpoint. So I know that R is in the middle of these two things. Okay. It then tells me afterwards that PR is congruent to SR. 1, 2, 3, 1, 2, 3. Please do that. What is the reason? Why can we say that? Well, from before, if we saw the word midpoint, we knew we were going to use definition of midpoint. And then here, now it's saying that the triangles are congruent to each other. It's saying that this triangle is exactly the same as that one. How can we say that we prove that? Well, side, 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 the topic that we're talking about in the first half of this video. We proved all three sides are equal, so the triangles are equal to each other. In this one, it gave me this. It gives me this. Oh, it's only one piece of information though. Okay. All right, label your picture. JL is here. MN there. K is the midpoint of two things. Okay. K is the midpoint of not one, but two things. That means I'm going to use that trick that I just used twice. I see midpoint. I'm probably going to have definition of midpoint twice. But let's see here. K is in the middle. It's in the middle of JN. So this piece is going to match that piece because it's in the middle. And it's in the middle of this one, too, LM. So 1, 2, 3. Those two pieces are going to match each other. Okay. Yeah, and the reason I knew both of these was definition of midpoint twice. The final prove line says, okay, now the triangles are congruent to each other. How can you say that? How can you demonstrate that? Well, you've proven that all three sides match each other. Side, side, side. All three sides match. Okay, fill in your own. Now, it doesn't tell me here. AC is congruent to AD. The reason reason for that? Given. They gave me that. They gave me another thing. CB is congruent to DB. Okay. And, oh, there's one more thing. There's one more important thing. They gave me that. Where do I put this? Always at the bottom. So I'm trying to prove the triangle ABC is congruent to triangle ABD. And then my reason's not prove. If you put prove in the reason, I'm gonna throw things at you. Don't do that ever. Don't ever put prove there. Okay. All right. Now let's label our picture. AC matches AD. CB matches BD. All right, well, probably you're smart at this point. You can figure out, I'm gonna try to prove that this is with side, side, side. Like that's what we're trying to do. That's the topic here. So I know that's the answer. I got one side is equal to it, another is another, but like I don't have that third side. I don't have the midpoint, I don't have anything like that. I don't have any information. But I want you to think, okay? If you took this shape, and you were to pull it apart at the middle, like if I were to drag this one down or that top one up, that line AB would cover both of those triangles, right? It wouldn't just disappear, it would cover both of them. Okay, so that AB is part of both triangles. Well, anytime we see, I'm gonna guess keep blue, anytime we have this overlap in a triangle, it's always gonna look like this. AB is congruent to itself. Remember when we joked about like, why is that even a thing that we have to do? Like, of course 5 equals 5. Like, why would we need to write that? This is the reason why. Okay. AB is congruent to AB. The reason there is gonna be reflexive. The reflexive property, because remember, if you look into a mirror, it's reflecting and you see exactly yourself. AB is congruent to AB. That is another trick. You will always use that. So if you see an overlapping, you know you're going to use reflexive. Just like if you see midpoint, you're going to use definition of midpoint. Okay. All right, second topic of video. Different way to prove triangles congruent. Now we're talking about the SAS. We got side, angle, side. Okay, so we got two sides and an angle that is in the middle of them. Here's the important part. It needs to flow. We have side to angle to side. That's how it has to go. So right here, I have side number 1. If I drag my pencil and flow, side to angle, angle to side. Okay, it has to go like that. It needs to be sandwiched. Side, angle, side. Side, angle, side. Has to, okay? If you suddenly just like have two angles here and two sides and the angles over there, that don't work. Okay, you need the sandwich. You need to have this, exactly this. All right, label your picture. We got some givens. Just 2 though. Okay, that one's given. And this one's the given. It has the prove already. Okay, label your picture. JM. This one, congruent to LN, that one. Angle time, JMN. JMN is talking about this corner here. LNM. LNM is talking about this corner there. Okay, I've labeled my picture. Now I know, because again, you know, you're smart kids, right? You know you're gonna do the SAS, right? You got side, angle, side. It's the topic of this part, you know it's gonna be there. But now it says MN is congruent to NM. That's saying that this one, MN is congruent to NM. Okay, it's not reflexive now because it's not exactly the same. This is a little tricky, right? MN is not MN. What they've done is they've swapped places. Remember when it was swapping, it was symmetric. So in this one, two properties that do functionally the same thing but are technically different. So if they swap, it's symmetric. If it's exactly the same, like in the one we just did, it's reflexive. Okay, given two pieces of information. All right. We got first thing given. Boom. We got second thing given. Boom. I got my proof down here that's already caught up for me. Okay. All right. And let's see here. Looking at my statements, are there any freebies? Bisect, I'm coming back for that. But hey, look, BD is congruent to BD. That's two things looking exactly like itself. That is reflexive. And while I'm here, let's label the picture with that. BD is BD. Okay. All right. Now let's go back and label the picture normal. AB is this side, and CB is that side. Okay, now I have to deal with this bisect thing. It says that something is being cut in half here. Because bisect means to cut in half. So it's saying ABD. ABD is this piece here. Oh, I don't want that, I want normal. That piece there. It's saying that piece is congruent to CBD. CBD is this piece here. So those two pieces are congruent to each other. Okay. Well, just like midpoint, we saw midpoint, we're going to use definition of midpoint. We see bisect, we're going to use definition of bisect. And then the last one, well, we're in the SAS part of the notes. So we know that's the answer. But why? Let's look at the picture. So we needed to flow, remember? It needed to be side, angle, side. It needed to be sandwiched. And if I go from my one tick mark to the one that I have more tick marks, it's gonna be side, meets up at the angle, and then side. Up top here, side, angle in the middle, side. I do have that sandwich. I have two sides with an angle in the middle. I have to have that. V is the midpoint. Okay, so I'm probably gonna do some definition of midpoint stuff here. Just putting it out there. V is the midpoint. That is a given statement though. And then my label, okay. V is in the middle. So it's saying that WV is congruent to ZV. And it's saying XV, this one here, is congruent to YV. Okay. All right. So I have some statements. This being congruent to that, that's going to be your definition of midpoint. And the second one, right, because it was the midpoint of two things, the second midpoint's going to be down here. Okay. I mean, we know we're going to be set. Let's call it what it is. I got two sides, I already did that. The angle, okay. It's telling me that the angle's here, it's this one. It's telling me what angles I need to look at, which is nice of it. WVX, this one here. It's congruent to ZVY, this one here. Okay, and it's saying that they're equal to each other. It's telling you that they are. How do you know? Well, what is their angle relationship to each other? It looks to me like they are vertical, right? Make that cross, vertical. Vertical angles are so important. They don't go away. Oh, let's look at it, right? We got that side, meet up at an angle, go to the other side. over here, I got the side, angle in the middle with the side. We got the sandwich, got the SAS sandwich. Is this the last one? Yes, ma'am. All right, we have a couple givens, and I see a parallel. That parallel is important. That parallel probably tells me that I'm gonna look for some kind of angle relationship statement. But before that, get my free points. Okay. All right, label HI. It's congruent to JG, boom. Lines are parallel. Which two lines, though, is the question. HI, this line, really? Okay. It's parallel to this one. So that means those lines are going in the same direction. They're never ever gonna touch, ever, ever, ever. If I go down by my statements, right, if I just look at what they're giving me, it also tells me that HJ is congruent to JH. HJ is congruent to JH. That's gonna be that piece right there. Okay, so I either know that if I have a line representing itself, it's either gonna be reflexive or it's gonna be symmetric. And it looks to me like these things swap. It's not exactly the same. So that's gonna be symmetric property. Okay. It tells me what angles I need to look for. It's very nice that it does that. I don't have to really think. Well, I should be probably thinking a little. GJH. GJH is this angle here. And that's gonna match with then IHJ. That one there. It's telling me that they are congruent. Okay. So what's the relationship there? The parallel lines are the key. The parallel lines. If I look at these and I ignore everything else, I ignore this side of this box and I ignore this side of the box, I have two parallel lines crossed by a one connecting transversal. They're both inside the parallel lines. So they're interior. This one's on the left, this one's on the right, so I have alternate interior. They're alternate interior angles. And now I have this nice sandwich, side, angle, side. Side number one, angle, side number two, SAS. Okay. So lots of things thrown at you there. Okay. Take a moment, like go back and review this.